So if we're going from decimals to minutes and seconds, you need to multiply this decimal piece by 60, and then you will get some number, whole number, and a decimal. That whole number is your minutes. You need to take your new decimal and multiply that by 60 again, and that will be your seconds, okay? So then when you're going the other direction, take your minutes, divide by 60. That's going to give you some decimal. Then take your seconds, and you're going to have to divide by 60. That's 3,600. And you're going to get some other decimal. Add those two decimals together, and that will be your decimal piece of your degrees, okay? So you're literally either multiplying by 60s or dividing by 60s, depending on which way you're going, all right? For the next one, if we're going from, now if you do not see a little degree mark and they're talking about an angle, it is radians. If you see a degree mark, it is degrees, okay? So if you're going from radians to degrees, you want to say 180 over pi, and your answer should be degrees. All right, I do not want these in decimals. I want these in whole numbers or fractions, all right? Which means if I'm going the other direction, then I'm going to multiply by that reciprocal, pi over 180, simplify your fraction. Length of the arc. What is my formula for length of the arc? R times theta. There is another formula, right? The other formula is degrees. So whatever your degrees are over 360 times 2 pi r, that's your circumference, okay? That we learned that in pre-cal, or actually in geometry, all right? Whatever portion of the circle you have times the circumference, because that's what your length is. If you are doing area here is what? 1/2 r squared times theta, or again, whatever portion of the circle you have times the formula for the area of a circle. Those two give you the same answers. So whichever way you want to remember it is perfectly fine with me, okay? However, know that when it says theta on these, it means in radians, which by the way is why you take the percentage of the circle that you have and multiply by 2 pi. Okay, that's why you're multiplying by it, okay? So when I do this, I'm just gonna plug it in. S equals R, that's 4, times theta. Well, theta is going to be 240 times pi over 180. All right? Or you can plug it in the other way. 240 over 360 times 2 pi r. If I want to do the area then, I'm going to say 1/2 r squared times 90, but that's in degrees. I need it in radians. All right? You just need to know your formulas. One way or the other, you need to know those formulas. Help me out. If I am wrapping a rope around a drum, y'all know what a drum is, right? It's a circular, it's a cylinder of some sort. What am I measuring? Your perimeter circumference. The circumference. I am measuring the arc. We just did arc measure, didn't we? Right? So arc measure is this little guy, or your percentage times 2 pi r, right? So I have everything I need here, don't I? What is my radius? 3. My radius is, hey, pay attention to what you've been given, all right? They gave me an angle. That is going to help me get my theta, right? My theta is going to be that 43 degrees times pi over 180. That's how much rope would be wound around the drum, right? Does that make sense? You're looking for the portion of the circle that got covered by a rope. That is the arc length. That's all they're saying there. All right. Look at the next one. A lawn sprinkler located at the corner of the yard is set to rotate 90 degrees and project water out 30 feet to the nearest square foot. What area of the lawn is watered by the sprinkler? Well, I just handed you what you're looking for there. You're looking for area. All right. We just did area. Area is 1/2 r squared theta. Okay. If you are at the sprinkler and he is projecting out 30 feet, they gave you the radius, by the way. All right. They didn't give you the diameter. They gave you the radius because it's from the center out. That is 30 feet. They gave you the degrees. You need it in radians. So 1/2 r squared times theta. And of course we need this in radians, pi over 180. Okay. Know your formulas. Also know how to recognize what formula you need. Am I talking about a sector measure? Am I talking about an area measure? What am I talking about? an arc length. What am I looking for here? What is created by the sprinkler? A wedge is created by the sprinkler, okay? So if they have given me 55 miles an hour, they have given me linear speed. If I am traveling 55 miles an hour, I am traveling linear, right? I'm driving on a road, going linear. I'm not going in circles, okay? Revolutions would be circles or angular. They're talking about linear. So they have given us linear. We know that linear is the radius times the omega. All right, omega actually represents angular speed. They gave me linear speed. I want angular speed. Now, I will say they gave me linear speed in what units? Miles per hour, all right? I am going to have to divide by the radius here, okay? My radius is in what units? Feet. I cannot just divide miles by feet. I have to have the same measure here. I'm also going to be doing radians per minute. So I would, before I divided by my radius, I would convert my miles per hour to feet per minute so that I'm in the right units, and then I can just divide by my radius and be done. Okay, does that make sense? Because omega is what I'm trying to find here. Okay, so I'm going to do my conversion first. Hours. My hour is going to go on top. How many minutes are in an hour? 60 minutes are in an hour, and that will get my conversion. Get rid of my hours. That will give me my minutes. My next conversion. How many feet are in a mile? 5,280. 5,280 feet in 1 mile. And that will give me this conversion. My miles will cancel out. I will have feet per minute. That is what I want. All right. And so if I multiply this across and get this answer, that is my linear speed and what I want. I know my radius, 1.3, because they gave me diameter, right? Omega is what I'm trying to find. So when I do all of this, multiply across, I will then divide by 1.3. And that will give me 3,723 radians per minute. Multiply, 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 divide by 60, and then divide by 1.3. You should get 3,723 radians per minute. All right, so as I said, SOHCAHTOA is what you're going to use for all of this. All right. So know this, know this. The other key feature here is labeling it correctly. All right. Hypotenuse is easy. Wherever you see that red triangle, the guy opposite him is my hypotenuse, opposite the right angle. All right. Wherever you see the theta, the guy opposite him is opposite. And that leftover little guy is adjacent. All right. He's connected to your omega. To your theta, not omega. So if you label it correctly and you know SOHCAHTOA, there's no reason to not get this correct. You may have to solve using Pythagorean theorem for a third side. So you may have to use this. Remember, c squared is always your hypotenuse. So in this case, we don't have the hypotenuse, and they want sine, which is opposite over hypotenuse. So I will need to solve for hypotenuse. I do not want decimals when I'm asking for a trig ratio here. I would say round to the nearest if I wanted a decimal. You need to manipulate your radicals and your fractions correctly. All right, so by that I mean a squared plus b squared. We should all know how to do this, right? 11 squared is what, 121? Plus 4 square root of 3 squared is 4 squared, 16, times 3. So that's going to be 48. And so you're going to get 169, which actually has a perfect root of 13. All right? And so I know my hypotenuse here is 13. They want sine opposite over hypotenuse. 4 square root of 3 over 13. Find the measure of each angle. You are still going to use SOHCAHTOA, but you are going to use your inverse trig functions here. So they want me to find this. I don't need to use Pythagorean theorem here. They've given me two sides. Figure out which trig function you need based on those two sides. For this one, I have opposite and I have adjacent. So which of these three trig functions am I going to use? I'm going to use tangent. So the tangent of theta should equal opposite 8.9 over adjacent 9. So in my calculator, I'm going to say tangent inverse of 8.9 divided by 9. And that's going to give me a degree. This is going to be in degrees when it is a right triangle. Right triangles don't use radians. They use degrees. All right. So you want to make sure your calculator's in degrees when you're doing all of these that look like this and your word problem for right angle trigonometry. Make sure you're in degrees. All right. But once you put it in, round to the nearest tenth is what you're doing. All right. So round to the nearest tenth, you should get 44.7 degrees. Last one says solve for the side, and they gave you one side, so obviously you can't use Pythagorean theorem, and they gave you one angle. So once again, you're going to use SOHCAHTOA, and you're going to figure out which side you have. So I'm looking at this guy. Here's my angle that they're talking about. This is opposite. This is adjacent. So the tangent of 30, which is by the way a known tangent, equals opposite 4 over adjacent x. All right, so I'm going to end up dividing 4 divided by the tangent of 30. 4 divided by the tangent of 30 here. And you round it to the nearest tenth, you should get 6.9. All right, a team of climbers must determine the width of a ravine. All right, so we're talking about some ravine that we don't know, right? They want to know how far across it is. So this is what they want to know. How far across is the ravine? How wide is the ravine? It says, in order to set up equipment to cross it, so if the climbers walk 25 feet along the ravine from their crossing points, they're going to go here and they're going to walk 25 feet. Sight the crossing point at the far side to be a 35-degree angle, which is what you little see these guys on the side of the road with little tripods, right? That's what they're doing, trigonometry. All right, so they sighted across here. So from here to here, it is a 35-degree angle. They want to know how wide it is. This looks like a right triangle problem to me, right? Actually, it looks exactly like what we just did. So we're going to label it. We're going to say this is opposite, this is adjacent, tangent of 35 should equal opposite over adjacent. When you multiply the tangent of 35 by 25, you get 17.5 feet. It wants it to the nearest tenth. On any point, sine is going to be y over r, cosine is going to be x over r, tangent is going to be y over x. And then you have your reciprocals, okay? So cosecants r over y, secants r over x, cotangent x over y. All right, so what is r? Well, we have x and y. R is going to be the square root. It's just Pythagorean theorem, x squared plus y squared equals r squared. All right? So if I am looking for a sine or a cosine or a secant or a cosecant, I'm going to have to solve for r. If I am looking for a tangent or cotangent, you have everything you need. Just put them on there and reduce, okay? So this is cosecant, which is reciprocal of sine. So I actually need r over y. So I'm just going to solve it. R is going to be the square root of 9 squared, negative 9 squared, and 9 squared are the same thing, plus 18 squared, all right? And then solve. All right, so square root of 405. I actually want you to use your factor tree here. So do this guy, 5 and 81, 9 and 9. So 9 squared of 5 is your r. They want cosecant, so it's going to be r, 9 square root of 5 over y, 18. Simplify that guy, square root of 5 over 2. For the next type, we are moving to unit circle. When you see the word reference angle, we're talking about unit circle. So I want to know how far away from the x-axis I am. Well, x-axis is 180 there. So 180 minus 120, I am 60 degrees away. That is my reference angle. That's the first part of the question. Then they want the cosine of a 60-degree angle. What is the cosine of a 60-degree angle? It is 1/2. What quadrant am I in? I am in the second quadrant. If I'm at 120, cosine is negative in the second quadrant, so that is going to be a negative 1/2. Those are my two answers there. If you know those three angles, you can answer any question about anything on the unit circle, right? Other than your quadrants, and those are just 0, 1, 1, 0, and so on and so forth. But those three will give you every angle. And so that's what I'm trying to reiterate here. Know those three, 30, 60, 45, okay? Graphing. All right, so graphing, you do need to know amplitude is the absolute value of A, period. 2 pi over B. Phase shift, that is negative C over B. And vertical shift is just D. And we're talking A, B, C, and D. Remember, it is, B is actually the number in front of your theta here. The number in front of your theta. All right, so for sine, remember for sine graphs, you start at your 0, you go to your peak, back, down, and over. You need to know your quarter marks. Cosine, you start at your high, middle, low, 3/4, high again. All right, so you do need to know those quarter marks. So for this one, if we were trying to figure out the amplitude here, we would say the amplitude is the absolute value of A, which is 4. For our period, we would say 2 pi over B, and our B is 1/2, so you're going to change flip. That will be 4 pi. Our phase shift is going to be negative C, so negative pi over 3, over B, which we know is 1/2. So we are going to change flip. That will be a negative 2 pi over 3, or you're moving to the left is what you're going to think about here. And then our vertical shift is just our D, so that's going to be -1. So the first thing I'm going to graph here is my vertical shift. I am just going to make a dashed line here at -1. Now normally I would start at 0 and I would end based on my period at 4 pi. So normally I would start here at 0 and end at 4 pi. But I am shifting left 2 pi over 3, which is almost pi, but not quite. So if you think of it this way, I'm going to move this over 2 pi over 3. And of course I would move this guy as well. 2 pi over 3. And so if you run off the graph a little bit, that's okay. 2 pi over 3 left. And so now I'm moving both of my endpoints 2 pi over 3. My starting and my ending. This is a sine graph, so I'm going to start at 0. And in this case, my 0 is on this vertical line. I need to figure out my halfway marks. And so if I'm doing a halfway mark, it would be about right here. And then my halfway in between those would be my quarter marks. And again, you can estimate that. So I'm starting at my starting point, which is here and which is on the vertical line here. My quarter mark, which is right here, is going to go up 4 from there. So I'm going to go 1, 2, 3, 4, and I'm going to go all the way up 4 from my starting point, which is going to be up here. And my halfway point, I'm going to be back at my midline. At my 3/4 mark, I'm going to go 4 down from my midline. My midline's -1. Then I am going to go all the way down to -5. And then when I get back to my ending, I'm going to end back at my midline. And so it's going to look something like this. And then of course it would keep going. Work from the inside out for these, all right? Work from the inside out. Remember for sine, they want from -pi over 2 to +pi over 2. For cosine, they want from 0 to pi, first or second quadrant, when you're doing your arc or your inverse. So if you're doing the inside, answer the question. If you're doing the outside, stay in your quadrants that you want if you're doing the arc sine there. Or arc cosine, rather. All right? So if you were to work this one, you would say sine of 0, which means you're going to go to your 0 degree angle or your 0 radians, since this doesn't have the degree mark, and you're going to say, what is your sine value here? Well, your sine value here is 0. That's your y value. So 0, this inside equals 0. And now we're going to work the outside, the inverse cosine or the arc cosine of 0. Now this is asking for what angle gives you a cosine value of 0. And remember, for arc cosine, we use the first and second quadrant. So now we're going to find 0 in our x value and give the angle. So anytime you have the inverse function, you are trying to find the angle. And so if I look here, this is where my x is 0, and the angle that gave it to me was pi over 2. And so the inverse cosine of 0 is going to be pi over 2. Let's look at one more, all right? So we're going to do one more of these. This is asking us to find the secant at theta equals 0. So if you remember, secant is 1 over my cosine. All right, 1 over my cosine. So then I will find my cosine value at 0. My cosine value is the x, which is 1. And so it's going to be 1 over 1. So this whole part, secant of 0, or the x value at 0, is 1 over 1, which just gives me a 1. And now I'm going to work the outside, the inverse tangent. So when I'm using the inverse, again, they have given me the trig function and I want my angle. So now I'm going to say tangent deals with the first quadrant or the fourth quadrant. This is positive, so it's first quadrant. And I want the angle that gives me a tangent of 1. Well, the only way you can have 1 for tangent, remember tangent is going to be your y value over your x value, all right? And the only way you can have a 1 is if they are the same, and there's only one angle that has the same x and y value, and that is pi over 4. So if I'm using my inverse tangent, I'm looking for the angle that gives me a tangent of 1, and so the angle would be pi over 4.